the north coast of Canada lies one of nature's weirdest predator-prey scenarios: moose and killer whales. Pretty odd, right? Now, how would we model this? The Lotka-Volterra equations, also known as the predator-prey model, are a pair of famous differential equations, and one's instrumental to model our scenario. The first of the two equations is prey prime of t, the change in the prey population with respect to time. This equals to A times the prey population minus B times the prey population and the predator population. The second is predator prime of t, the change of the predator population over time. This one is defined by negative c times the predator population plus d times the prey population times the predator population. But what do these equations mean? As you can see, they show how when the predator population increases, the number of prey decreases, which increases the number of predators to eat the prey, creating this pattern. But what if we wanted it to look like this? Let's go back to the equations. Well, these represent the change in our moose and killer whale populations. So to get a horizontal line where there is no change in population, we need to set these equal to 0. Let's start with our prey, the moose. After we set this equal to 0, we can rearrange it like this. Then, by dividing out the initial prey populations, we see that the predator population must equal A over B. Rinse and repeat, and we find that for the predator population to not change, the initial population of the prey must be C over D. These produce what we call equilibrium. Now, let's have some fun. One of the many problems students are given is to determine whether a government's use of pesticides actually succeeds in decreasing the insect, or the prey, population, by putting a negative factor, U, in prey prime of t, and a positive factor, V, in pred prime of t. For our scenario, let's imagine this to be some moosicide to keep those silly moose out of the ocean. Let's check the equilibrium population by following the steps above. Turns out this has the exact opposite effect. More moose are in the ocean, and there are less killer whales to eat them. I hope the next time you're at the coast, or even possibly whale watching, that you can't help but to remember nature's absurdity and the math behind it.